One of the awesome things about analog video is how you can use really simple electronic components to do interesting things to the video signal. If you try to do that with digital video, you find yourselves very quickly in the land of FPGAs and it becomes quite complicated. You may as well just be working on a computer. There's nothing tangible about the electronics that you make. I love the analog audio world where people build their own guitar effects units and modular synthesizers and things like that, just using basic op amps. And you can do that in video too. For example, you can take a basic component like this potentiometer, variable resistor, knob, and make yourself a pretty good video mixer. Of course, that depends on your definition of both good and pretty. So what we have here is two NTSC security cameras. This one's pointing over at my electronics workbench. Hello. And this one over here is pointing back at you. You can't see it though. It's plugged in, but it's not plugged into the TV. It is plugged into that little potentiometer circuit we were talking about earlier. This is lovingly known as a dirty mixer. It's really not much of a circuit. You have one camera going into one leg of the potentiometer, another camera going in here, and the output coming from the wiper going back into this CRT TV. Why do they call it a dirty mixer? Well, with one twist of the knob, you can seamlessly move from camera A to camera B. Now, whether it's pretty or good, that depends on the viewer, but it's definitely interesting. There's a lot of people who make really cool, interesting video art exploring this sort of liminal space when you wildly corrupt analog video standards. But I wanted to bring a bit more control to this. I wanted to let you mix HD, true color, analog video using a simple potentiometer and putting you in control of when the glitching happens or if it happens at all. I wanted to open up an entirely new world of doing things with analog video, and I think I've done it. So this is me in analog. I have one camera looking at me there. It's my Blackmagic camera. I have a second camera here looking down at the mystery box. They're both shooting in different resolutions, different frame rates, different color spaces, but with one twist of a dial, we have a relatively smooth crossfade. Let's go back again so you can see my pretty face. All right, we should be back at me. Admittedly, the video quality is not perfect. This crossfader is definitely not how you design a crossfader, even for audio. It's got a bunch of problems with it, but it works so much better than the dirty mixer, despite being the exact same circuit. Let's take a look at it again. Here we have the board. It's just a potentiometer, but you can see here that we have three lines in from each camera and 3 lines going out. So we're working with component video. Component video is nice for a couple of reasons. One is it natively supports HD resolution. The problem with composite video, which is video going over one cable, is that you have to compress all 3 channels, so the brightness and 2 color channels, into a single signal. And the way that they do that is through RF modulating with using a carrier frequency, the color information on top of the brightness information. That means that your total resolution is limited to the frequency of the carrier. So you don't see composite video above sort of NTSC PAL resolutions. You could theoretically make it a lot higher, but then you'd have to have a much higher carrier frequency, which means that for HD video like this, you'd need to be having a carrier in hundreds of megahertz, which gets very quickly out of fun electronics tinkering and into RF engineering world. The other challenge with composite video is that to extract the color information because of the clever RF encoding, you need clever electronics. And again, it becomes an engineering challenge if you want to do smooth, clean things with color. Yeah, it's cool to make glitchy colors and all that sort of stuff. You can definitely do that with component, but it's the only really easy thing to do with composite is to get really sort of messed up, highly saturated colors. And if you want a little bit more control, you need component video. The other advantage of component video compared to composite, even at the same resolution, is that component video has a lot more bandwidth dedicated to color. So you get much higher dynamic range in the color spectrum. So that's my quick demo. Let's go over to the bench and look into some details of how it all works. To understand what makes a dirty video mixer so dirty, it's worthwhile to plug the camera into our oscilloscope and have a quick reminder of the anatomy of an analog video signal. As you probably all know, analog video is sent by scan lines, horizontal lines, progressing down the screen, gets to the bottom of the screen and starts from the top again. That's the vertical refresh. Here we're looking at just a single horizontal scan line. This main section here of the analog data is each video line. Let's see if we can, you can change it around by moving our hand in front, getting one sort of scan line at a time. This little downward going negative spike here signifies the start of a new horizontal line. This boop to boop here, that is the technical name, or otherwise known as a color burst, contains synchronization information for color. And here again is the video line, and we start all over again. So to understand why an dirty video mixer is so dirty, let's plug in a second camera and we'll see two of the main problems. There are others, but we'll just focus on two. Let's turn on our second one. So yellow line coming out of this camera, blue line coming out of this camera. And these cameras are in all shapes and ways and forms identical. They are both outputting the same video signal in terms of frame rate, color space, all that sort of stuff, but they are not synchronized. And you can see this blue one here is, while they're both at NTSC frames per second, which is 30-ish, they're not exactly the same. And so what you see is this one moving across the screen. So you get this rolling effect. You probably saw it in the video that we're looking at, this rolling effect as one frame slowly shifts left to right compared to the other one. The other issue really has to do with the color burst. The way that you get analog video over one wire is this overall level here, how high up and down this is, represents the brightness of the image. If we pause and just look at a single trace and zoom in a bit, it's squiggling up and down. And it's squiggling up and down using a carrier frequency set by the color burst, and the phase shift information here encodes the color. So you are sending 3 channels of color over one wire, where the main channel, or the luminance channel, the thing that your eye is most sensitive to, is being sent as the overall amplitude. But the color loses bandwidth because they encode it using this color burst into the squiggles that are lying on top of this line. And so when you have a second camera turned on, not only are your frames out of sync, moving sort of left to right, but these color burst signals aren't synchronized either. So you're never going to get the right color from one video to the next, or one camera to the next. All right, so let's have a peek behind the curtain and see how I was able to pull off a clean, dirty mixer. The answer is this guy here. Of course, it was sleight of hand and subterfuge, and a project that I've been working on for the last 6 months, pretty much full time, hundreds of hours of programming, and I won't say how many thousands of dollars have gone into building this so far. What we have here is a development board built around this blue board here, which contains a very special ASIC, so application-specific IC. This is not available to consumers. I've spoken with the manufacturer and they think the project is interesting, and they've agreed to provide me with one of these boards for me to build on top. And on top of that, I've put 2 boards here. This is a dual digital to analog converter board, and this is an ADC board with a microcontroller on there. And so this blue chip here is really the secret sauce. It takes 4 HDMI ins and 4 HDMI outs, and it can take any HDMI 2.0 video, so up to, what's that, 4K 120p, 36 bits per pixel, so a lot of bits being shoved around, 4 or 8 of those at the same time. It processes the video, it does the color space conversion, the frame rate conversion, resolution conversion, spits it out as digital signals that then go to these digital to analog converters. So what you were seeing was 2 digital to analog converters that were synchronized completely using this ASIC. You may have noticed that I've got more dynamic range in the video you're seeing now. This is being recorded straight from the digital camera. And that's honestly the problem of the analog to digital converter that I was using. I was using an off-the-shelf ADC, a very good one, but it doesn't provide the bit depth that this camera can provide. But that's what this board here does. This is an analog to digital converter board. That'll probably be the subject of the next video. It has 36 bits per pixel, so very deep color for analog video. and that will pair well with these DACs to give a very high dynamic range workflow for working with analog video. The intention is to build this out completely into its own standalone board. Right now we have two analog outs. The plan is to have 4 digital ins, 4 digital outs, and an analog to digital converter going back in. The next video will cover the ADC, and there's a lot more tricks up my sleeve. So follow along. If you want to learn more about this project, feel free to subscribe, comments. I'm really excited about this project. I've really poured my heart and soul into bringing this thing to life. It's been a project I've been dreaming about for years and years. And I'm hopefully other people are interested in it. Maybe I'll bring this thing to market one day, but right now this is like a dream box for me for working with high dynamic range, high resolution video in the analog domain. And please stick around and follow me on this journey. Thanks a lot.